A projectile is fired from a tank with initial speed 400 meters per second. Find the angle of elevation that can be used to hit a target 3000 meters away. Okay, here is the case. So we can have more than one angle, by the way. So initial speed is given 400 meters per second. So we can write initial velocity in terms of vector. That's 400 cosine theta, 400 sine theta, and we are interested in finding this theta. As usual, we start from the acceleration, which is negative 9.8 j, 9.8 value, and it's going down, that's why negative. Down means y direction, there is no x, so it's just j. So in terms of vector, we can write 0, negative 9.8, that's the acceleration. Now we integrate both sides with respect to t, we get velocity vector, which is, there's nothing means 0, negative 9.8 t plus c1. Now use the initial velocity to find c1. So using this, that means take t equals 0. That gives v at 0, initial velocity, which is 400 cosine theta, 400 sine theta, that's initial velocity, equals, we are putting t equals 0, so 0, this is 0, plus c1, subtract 0, 0 from both sides, so we can isolate c1, we don't have to subtract. So c1 is in fact 400 cosine theta, 400 sine theta. Now we plug this back, we plug this value back here. Okay, c1 is just this, thus the velocity is this plus c1, c1 is this, so 0 plus 400 cosine theta, comma 9.8 t, this negative 9.8 t plus 400 sine theta. Now we integrate again to find position. Position is, this is just a constant, so antiderivative is 400 cosine theta t, comma, here is 9.8 t, antiderivative t square over 2, so over 2 means divide by 2, 4.9 t squared plus, this is just a constant, so 400 sine theta times t plus constant of integration. Now initial position, we can say this is 0, okay? When we started, the projectile is fired from tank here, let's say from ground, that's the initial position, 0, 0. So putting 0, 0, this becomes just 0, 0, 0. So we don't have to write that. So that thus the position at any time will be just 400 cosine theta t, comma, negative 4.9 t squared plus 400 sine theta t. This will be 0, 0. Now this is x means horizontal distance, this y means vertical distance, and we know for this, when it hits this target, that means horizontal distance is 300, so this is 3000, and this is 0 because when it hits the ground again, object somewhere, so this is 0 and this is 3000. So from these two we should be able to get the value of theta. Okay, this implies 400 cosine theta t is equal to, that's the horizontal distance, 3000, and negative 4.9 t squared plus 400 sine theta t equals, that's 0 when it's ground. Now we want to solve these two equations and get the value of theta. To find this angle theta, so let's solve for t from the first equation. T is in fact 3000 over 400 cosine theta. Let's find T from here as well. From these two terms we can factor T out. That leaves negative 4.9 T plus 400 sine theta equals 0. So either T equals 0, that's the initial place, and from this equation move this over, divide by 4.9, so T equals, move means negative and we divide by negative, so positive, so 400 sine theta over 4.9, and these two times should be the same when it is the ground, okay, because we are getting these two from the same place. So that means 3000 over 400, we can simplify a little bit. So this is just 30 over 4 cosine theta is equal to this time 400 sine theta over 4.9. So from this trig equation we should be able to get the value of theta. Let me cross multiply. 1600 sine theta cosine theta equals 30 times 4.9, that's 147. Now we got two different trig functions. We are supposed to isolate theta from here, which is a little bit of tricky here. We know that 2 times sine theta cosine theta, that's sine 2 theta. Okay, so that we can have theta in one place. So 1600 is same as 2 times 800, so this is 800 times 2. Then we have 2 sine theta cosine theta, for which we can write sine 2 theta. So this is same as 800 sine 2 theta equals 147, divide by 800 and take sine inverse. So 2 theta equals sine inverse of 147 divided by 800. Use your calculator and this gives you sine inverse of this is 10.59 degrees. At the same time 180 minus theta, we can have sine positive in second quadrant as well. So subtract from 180, you get 169.41. So sine of this angle is this fraction and sine of this is also this fraction. So this is coming from 180 minus theta, that's 2 theta. Then theta is divided by 2, so we get 5.3, and another is 84.7. So these are the answers. Final.